There is a question from JEE 2005. The question was, we are given a compound X, which is a benzene ring. Then there is CH3, H, Cl, CH3, CH3, again a benzene ring, and then an NO2 group. So it is asked that aqueous acetone is being mixed in the reaction mixture. What should be the products? Three options are given. So first we have to understand what is the possible reaction pathways. Since aqueous acetone is given, we all know acetone is CH3 double bond O, CH3. This is acetone. Aqueous acetone has H2 is also present in the mixture. Thus it's a polar protic situation. Now in a polar protic situation, generally SN1 reaction is preferred. So what can happen is this Cl will be eliminated, giving a positive charge here, that is a carbocation is formed at this carbon. Now as you can clearly see, it's a 2-degree carbocation. This is a 2-degree carbocation, and we already know that 2-degree carbocations are generally not stable. So we have to shift this carbocation. What are the 4 possible options here to shift? One is this H, one is this CH3, one is this CH3, one is this CH3. Okay, so obviously a H shift will be much faster than a methyl shift, and besides that, this benzene ring is pumped by these electrons. This O electron is being pumped in this benzene ring, whereas these NO2 groups are taking electrons from the benzene ring, making it more electron deficient. So this setup does not have electrons. This is electron deficient, as it was in the case of the last question, and this is electron rich. So obviously this electron rich setup can donate more electrons if a positive charge is being formed at this place than it is being at this place. So the charge will be shifted only to this side, not that side. This is the first concept which we are going to use in this reaction. So now let us see what options do we have. The 3 possible options are OCH3, HCH3, HOH, again CH3, CH3, NO2, this is, let's say it's given it's K. In L part, the OH group is at this position, that is everything else same, phenyl, OCH3, we have an CH3 group here, OH group is there, H, both methyl, and then phenyl NO2. Now you can be wondering where is this OH coming from. Once this carbon is formed, then the water which is present in the reaction mixture will come here to attack this positive charge and thus give us a OH group at this positive charge. So our only thing to decide is what are the positions where this positive charge can be present. So if this is the product, then the positive charge was at this position. If this is the product, then the positive charge was at this position. And if the third part is the product, that is phenyl OCH3 HCH3, again CH3 H, again CH3OH, phenyl NO2. So in this part the positive charge is here, hence there should be a methyl shift. This is, let's say, product M, the above one was L. So there can be a possibility that when the positive charge at this place, then H2O should have attacked, or after this H shift OH2 has attacked. So if at this position H2O is attacking, this will give us product K. If at this position H2O is attacking, it will give us product L. But in any case, we are not getting product M. So the only two possible products are K and L. Now the four options are K, L. Let me write all the options. Options were K, L, K, M, L only, M only. So we can get both K and L. The A option is our answer. It was again a question where we have to see the stability of a carb cation. Also there is some concept of shift, electron deficiency, the electron deficient benzene ring, which can be made by attaching a NO2 group to it. So these are the main concepts which was used in this question. The next question is from JEE 2005 itself. It was best reagent to convert cyclohexanol. Remember, only name of this was given, no structure of cyclohexanol was given, so you have to be good with nomenclature, into cyclohexene. So what cyclohexanol is? Our 6-membered ring. And as it is OL, that is an alcohol is attached to one of the carbons, we have to convert it in cyclohexene. That is this one. So basically it's a elimination reaction. We have to find out the best reason for this elimination reaction. The options which were given was conc HCl, conc HBr, conc H3PO4 and HCl plus ZnCl2. Now we have already discussed when we were studying elimination reaction that for the elimination of OH, the best group is conc H3PO4. Why is that? Because it is a good acid, so it can give an acid, make it OH2 plus, as well as it has phosphorus which has special affinity to O, as well as it has lone pairs which can attack on this, and basically it can act as a group which can eliminate OH2 much better, or it has lone pairs which can also attack on this H to help it in forming this alkene. So this has multiple functions here. This H3PO4 reagent is very useful for this elimination reaction. So the best reagent is concentrated H3PO4, which was C option. Coming to the next question. This is again asked in JEE 2005. The question is, we have to explain certain observations. The first one is, initial molecule is a benzene ring, then a 3-degree carb cation is formed. Okay, let's see, CH3, Br, and aqueous C2H5OH is given. Okay, we have acidic solution. So what this can do is, it is aqueous C2H5OH. This can fetch this Br. It can be a SN1 reaction. So a positive charge is formed here, that is a carb cation is formed, which is very stable, very much stable, because of the fact that it has two CH3 group attached to it, hence it's a 3-degree carb cation, plus it has electron supply from this benzene ring. So it's a very stable carb cation. So this carb cation has been immediately formed. After this, we have two possibilities. The first one is Br minus, which is in the mixture, can snatch this hydrogen, thus forming an alkene group. Or the other possibility is, this was the first possibility, the other possibility is CH3, and the solvent molecule, that is these oxygen lone pairs, come and attack. Okay, so the molecule will be OH C2H5, and there is a positive charge on oxygen, because here in this molecule it has 3 valencies. So what it does is simple dehydrogenation, and H plus is removed in the mixture, and it forms OC2H5 CH3 plus there is one more H plus in the reaction. Thus this H plus it is making the solution acidic. Hence this reaction leads to a acidic solution. So this is explained. In the second part, we are seeing that now the molecule is, there is a benzene ring, one Br is attached directly to this benzene ring, and then there are 2 methyl groups attached. Now you can see the only change this time is, in the last example the Br group was attached to this carbon, but in this case the Br group is attached directly to the benzene ring. And as I told you in the earlier example, if the bromine is attached to this benzene ring directly, then there is an electron donation, and this is a partial double bond in that case, which is very much tough to break, so making it a poor leaving group. Thus the reaction which was happening in the last case will not happen this case. There will be no SN1 reaction in this case. So the observation which was given was it is a neutral solution this time, which is very well explained, because if there is no SN1 reaction, so there is no H plus in the molecule in the solution at the end, thus it is giving a neutral solution, hence explained. The next question, it is from again from JEE 2005. Which is, suppose we have this initial 5-membered ring CH2OH and one more group is attached to this molecule, and H plus and heat is given. Now this is a very important sign. I have told you, if heat is given, then go for a elimination reaction. If it was simple H plus with a nucleophile, then you have to go for a nucleophilic substitution reaction. But in this case, it is clearly mentioned that heat is given. So what will happen is, this O lone pairs will attack on this vacant orbital of H plus, making it OH2 plus. Now this OH2 plus is a good leaving group. So it will give rise to a carb cation, which is initially 1 degree, but as soon as you see this setup, it should instantly come to your mind that it can undergo a shift, and the shift will be somewhat different in this case. That is, this is a 5-membered ring. So it can undergo a ring expansion. Okay, it can undergo a ring expansion also. That is, this bond is being moved to this position. So this carbon is suffering a loss of valency because this carbon is attached to this carbon in the previous case. Now this bond is shifted to this position. This carbon will no longer have this bond, hence a vacant position, hence a positive charge. And on observing, we can see then the new ring which is formed is a 6-membered ring, because a new member is being added to this ring. So let me draw a 6-membered ring. There is a methyl group attached to one of the ring members, and here will be a new positive charge developed on the same carbon which has methyl group attached to it. Now it is a very stable 3-degree carb cation. Okay, and it can undergo an elimination reaction. This H can be eliminated, hence a very stable alkene will be formed. This is our final answer. That is X. They have asked us to identify the X in this case. So X is this.